I'm Meg Urey. I'm a professor of physics and astronomy at Yale University. I do research on supermassive black holes, and I've been teaching physics, introductory physics, for over 30 years. I'm here to teach you physics. This course will cover the same topics that are covered by the AP Physics 1 exam. That includes the fundamental units of measurement, mass, length, and time, vectors, how to use vectors, how to add them, subtract them, and multiply them, kinematics, with how position, velocity, and acceleration depend on time, especially in the case of constant acceleration, such as free fall near the surface of the Earth. We'll also cover two-dimensional and three-dimensional kinematics, like projectile motion and relative motion using vectors. Then we'll move to why motion happens, which is to say we'll learn Newton's laws. Newton's second law in particular, F equals ma, what it means and how to apply it in solving problems, in understanding how objects move in nature. Next, we'll learn about work and kinetic energy and the conservation of energy, and which forces have an associated potential energy and how total mechanical energy is conserved. We'll learn about momentum, which is really important in collisions and also has a lot to do with how rockets work. The next topic is rotation. We'll learn about the kinematics of rotation, the angular displacement, velocity, and acceleration, and then we'll learn the equivalent of Newton's second law for rotation, torque equals I alpha, and how to apply it. We'll learn the new concept of angular momentum, which is really important in astrophysics, so pay attention to that, and the conservation of angular momentum. Then we'll study how objects don't move, static equilibrium. That is, how do we balance forces so that bridges don't fall down and people can stand up. We'll learn Newton's universal law of gravitation, and then we'll turn to simple harmonic motion, which happens when you have a potential with a minimum that is stable. We'll study waves. What is a wave? How does it travel? How does it behave? And then we'll look at the special case of sound waves. How do they work? And how do Doppler shifts and beats work? Finally, we'll go to electric charge. We'll learn about how it's a fundamental quantity in nature. And we'll discuss Coulomb's law, the attraction or repulsion between charges, and electric fields and how they're related to electric force. Finally, we'll look at currents and circuits with the elements of resistors and batteries and the rules of Kirchhoff's laws. So these are the topics I'm going to cover. These are the topics I'm going to explain to you.